All right, so we're doing systems of equations. This is going to be my part 2 lecture. And we did systems of equations last time. We did a little introduction to them. So we're going to be looking at the problem set part 2 today. Let's try the first one together. All right, so the first one says y equals x squared plus 2x minus 3. And the second equation says y equals 2x plus 1. So the top equation is going to be quadratic. It's going to be quadratic. The reason why we know that is because the highest exponent is 2. The highest exponent is 2. And what that means is when you graph it, you're going to get a U shape. You're going to get a U shape. And this is called a parabola. Parabola. Now the bottom equation is going to be not quadratic, but linear. Linear. And that's because when you graph it, you get a line. So that's y equals 2x plus 1. And notice that the highest exponent for this one is going to be a 1. 1 is going to be the exponent, but the number out in front is called the coefficient. Okay? So let's get started on solving this. Now, when I want to solve a system of equations, what I always do is I always put the quadratic part on the left side. And then the linear part I put on the right side. So I'm going to take the x squared plus 2x minus 3, set it on the left side. On the right side, I'm going to have the 2x plus 1. Okay, so now I've got it set up. What I want to do next is I want to get everything to the left side. So this 2x right here, I want to take that to the left side. Somehow get that over there. And the positive 1, I also want to get that to the other side. I need to find some way to get the positive 1 over there. So since both of these terms are positive, I have a positive 2x and I have a positive 1. Since they're both positive, I can subtract them from both sides. So I can subtract the 2x and I can subtract the 1. And then I have to do the same thing on the other side so that the two sides remain equal. So I need to subtract 2x on this side and I need to subtract 1 on this side. Okay, so now the right side is going to be equal to 0 because I've just gotten rid of everything on the right side. And everything is going to show up on the left side now. When I add like terms, I get x squared. The x squared doesn't really combine with anything, so I just bring that down. Next, when we look at the x terms, I have a 2x and a negative 2x. Those are actually going to cancel out. And the negative 3 and the negative 1 are going to combine to give me negative 4. So now everything is on the left side and there's nothing on the right side. And now I can make what's called my quadratic equation. What I'm going to do is I'm going to factor the left side. And since this is difference of squares, I know that I can take square roots at this point. I see a perfect square right here, and I see a perfect square right here. So now what's the square root of 4 going to be? The square root of 4 is going to be 2, right? What's the square root of the other thing, the x squared? What's the square root of x squared? That's going to be x. So now I have my two parts ready, and when I do difference of squares, I always put a minus in between and a plus in between. So I need a minus here, close that up, and I'm going to have the same parts over here, the x and the 2, but I'm going to have a plus in between. So the two factors are very alike, but they're also different because they have opposite signs. Okay, so what we just did was we factored the left side. And now I'm going to get two different equations once I set both factors equal to 0. I'm going to get x minus 2 equals 0, and I'm going to get x plus 2 equals 0. So these are two linear equations now that I can solve. So I've broken up the quadratic equation into two different linear equations. And now I solve them both for x. So here I can add 2 to both sides, and I get x equals positive 2. Over on the right side, I can subtract 2 from both sides to get rid of the positive 2, and I get x equals negative 2. All right, so now I have my x values. I can start making my ordered pairs now since I know what the x values are. I'm going to have an ordered pair with an x coordinate and a y coordinate. So the first point, I'm going to put in positive 2, and the second point, I'm going to put in negative 2. All right, now to find the y values, you need to plug back in. And it actually doesn't matter which equation you plug back into. You can plug back into the top equation right here, or you can plug back into the bottom equation right here. And usually when I do these, I choose the easiest one. And that's going to be the bottom one, since there's less things to do in the bottom equation. So let's take a look at that. The bottom equation is y equals 2x plus 1. So I'm going to write that out here and here. So I know what I'm plugging back into. I'm plugging back in for x because I already know what x is. What I don't know is what y is, but we're about to find that out. So for this one, I'm just going to plug in 2 for x and see what happens. I get 2 plus 2, 2 times 2 is 4, right? We're adding 1 at the very end. And I get y equals 5. So now I know what the y value is, and I can put that inside my first point. I can put the 5 in the y coordinate. So on the right side, I can plug in negative 2. I get 2 times negative 2 is negative 4. We're adding 1 at the very end, and I get negative 3. So that is going to be the y coordinate for my second point. So I put the negative 3 right here. Okay, so that's number 1. Let's take a look at number 2. All right, so number 2 says y equals x squared plus 5x minus 2. And the bottom equation is going to be y equals 3x minus 2. Now the top equation is going to be quadratic because I know that the highest exponent is 2. When I graph it, I'm going to get that U shape. And the bottom equation is linear. So when I graph this one, I'm going to get a line. All right, so we're going to put the quadratic part on the left side as usual. So I'm going to have x squared plus 5x minus 2. And on the right side, I'm going to put 3x minus 2. So that's the way I set it up. I always put the quadratic part on the left side. Okay, so now I really want to get everything on the left side. So the 3x has to go over here, and the negative 2 has to go over here. So to get rid of a 3x, I'm going to subtract 3x from both sides. So we're going to subtract 3x from both sides, and we're also going to add 2 to both sides. So that way we can get rid of this negative 2 right here. Okay, so the right side is going to be 0. We always set it up so that's going to be true. I bring down my equal sign. I'm going to get x squared plus 2x. And the reason why I don't have a number at the end is because the negative 2 and the positive 2 are going to cancel each other out. Okay, so now I have something that I can factor on the left side. So how can I factor this? This is actually a Gcf factoring problem. What you're trying to do is you're trying to find the greatest common factor between x squared and 2x. So you're basically asking yourself, what do they have in common, and can I take it out? Well, it turns out that the x squared and the 2x have only an x in common. So we can take out the x, but what are we going to be left with on the inside? We're going to be left with an x plus 2. X plus 2. And the reason for that is I need to multiply something by x to get back to x squared, right? That's going to be this x right here. So x times x gives me x squared. But I also need to get back to the 2x, right? So I do 2 times x to get me back to 2x. And now I have 2 different factors that I can set equal to 0. I set the first factor equal to 0, which would just give me x equals 0. No solving to be done there. Now I set the x plus 2 equal to 0. And for this one, I can get x by itself by subtracting 2 from both sides. And I get x equals negative 2. So I'll put a check mark beside that one. And I'm also going to put a check mark beside the x equals 0, because that is also an answer. Okay, so I'm going to have 2 ordered pairs, an x and a y and an x and a y. My x values are 0 and negative 2. And now we need to find the y values. So to find the y values, we need to take these x values and plug back in. I'm going to plug back into the bottom equation. Y equals 3x minus 2. So I'll put one right here, and then we'll plug back in. So for the first one, I got an x value of 0. So I'm going to let x be 0 and see what happens. I get y equals 3 times 0 minus 2. That's going to give me 0 minus 2, which is negative 2. So all I did there is I plugged in 0 to see what happened. When I go over to my next x value, I'm going to be plugging in negative 2. So when I plug in negative 2, let's see, what do I get? 3 times negative 2 minus 2. That's going to be negative 6 minus 2, which is negative 8. Good. So I put a check mark beside that. So now I'm ready to fill in my ordered pairs. The 0 is going to correspond with the negative 2. And the negative 2 is going to correspond with the negative 8. And that's it. I've got my two ordered pairs. So if you were to graph the quadratic equation and the linear equation, they would actually cross twice. They would intersect at 0, -2, and they would also intersect at -2, -8. So if you wanted to graph these two equations, that's where they would cross. Okay, we're going to do number 3 next. Number 3. All right, number 3 says y equals -2x squared plus 4x plus 3. And the bottom equation says y equals 2x minus 1. So the way I started off is I take the quadratic part and I put it on the left side. So I'm going to have -2x squared plus 4x plus 3 equals. And now I'm going to take the linear part and put it on the right side. So I'm going to have 2x minus 1. All right, so now I've got my equation set up. What I want to do is I want to get everything to the left side as usual. So I need to find some way to move this 2x over to this side and the -1 too. So the way I do that is I'm going to subtract 2x, since that's a positive 2x. And I'm also going to add 1 to both sides to get rid of this -1. So I need to do -2x under this 4x, and I need to do a +1 under this 3. Okay, so everything cancels out on the right side. So the right side is going to go to 0. Everything else is going to occur on the left side. So what do I get on the left side? I get -2x squared. I get plus 2x plus 4. All right. So now I have everything on the left side, and I have nothing on the right side. So now I start factoring the left side. So what can I take out from the left side? Because all three terms are going to have something in common. Do you know what that is? What do all the coefficients have in common? The -2, the +2, the +4. They can all be divided by what? They can all be divided by a 2, right? Or you could take out a -2. I'm actually going to try taking out the -2 and see what happens. But if you do decide to take out the +2, we'll still get to the same answer. It's just the path will be different. So I take out a -2, and what am I left with? I'm left with x squared minus x minus 2 equals 0. So I take out the -2, and because I'm taking out a negative number, the signs are going to flip. I used to have a plus here, but now I have a minus. And same way with this one. I used to have a plus here, but now I have a minus. And that's just because the signs are changing. So taking out that -2, that gives me x squared minus 1x minus 2. So can I factor what's left? Well, I want to be able to. If I can't factor it, I might have to use the quadratic formula. So what can multiply to -2, but at the same time add up to -1? I know that I'm going to have some kind of 2 times 1, because some way I need to be able to multiply to 2. 2 times 1, but I'm multiplying to a negative number, right? So that means that one of these numbers right here has to be negative. And since I'm adding up to what? A -1, that means that the biggest number has to be negative. So I'm actually going to have -2 and +1. So let's finish up the factoring. The first thing I do is I bring down my -2. This right here, I just bring it down to my answer. And then I'm going to factor the inside as x minus 2 and x plus 1. The way I'm getting that is I'm just taking these two numbers right here, these two numbers that I found. So x -2 and x +1. Okay, so now I have three different factors, right? This one, and this one. And I'm going to set them all equal to 0. So the first one, I set the -2 equal to 0. And that's not going to give me any answer at all because this is basically nonsense, right? So this one isn't going to give me an answer. The -2 doesn't really factor into anything that we're doing. So you could actually divide both sides by -2 to get rid of that -2. But I just wanted to show you what it would look like if you actually set it equal to 0. You're not really going to get anything from that, right? So we need to take the other two factors and set them equal to 0. So I'm going to set the x minus 2 equal to 0 and the x plus 1 equal to 0. I get two different equations, and we're going to solve both for x. All right, so the first one, I add 2 to both sides. I'm going to get x is +2. And for the other one, I'm going to subtract 1 from both sides to get x equals -1. Okay, so my ordered pairs. I'm going to have the ordered pairs with x values 2 and -1. So 2 and -1. I put those in the x coordinate. Now to find the y values, we need to plug back in. So I'm going to take that +2 and that -1, and I'm going to plug back into the bottom equation. So we had y equals 2x minus 1, y equals 2x minus 1. And the reason why I'm writing that one is because I don't really want to deal with the top equation. I'd rather deal with the bottom one. So when I plug back in that x is going to be 2, I get 2 times 2 minus 1. That's 4 minus 1, which is 3. For the next one, I'm plugging in -1 now. So I get y equals 2 times -1 minus 1. That's going to be -2 minus 1, which is -3. So now I figured out what the y values are. The 2 is going to correspond with the 3. So beside the 2, I'm going to write a 3. And the -1 is going to correspond with the -3. So I put the -3 beside the -1. And that's it. So if you were to graph these two equations, you would get something that looks like this. You would have a line running through it. So the U shape and the line are going to cross twice, right here and right here. And these are going to be the two ordered pairs that they cross at. All right, let's do two more. We're going to do 4 and 5 from the problem set. All right, number 4. So 4 is going to be y equals 3x squared plus 10x minus 2, and y equals 2x minus 7. So my top equation is going to be quadratic, and that's because the highest exponent is 2. My bottom equation is going to be linear, because my highest exponent is 1. So I'm going to take the quadratic part and put it on the left side. And I'm going to take the linear part and put it on the right side. So now I want to get rid of the 2x. I'm going to subtract it from both sides. And I also want to get rid of the minus 7, so I'm going to add that to both sides. So the minus 2x is going to go under the 10x, and the plus 7 is going to go over the negative 2. Now the right side is going to be 0, and that's because this cancels out and these cancel out. On the left side, I'm going to have a 3x squared, so I need to bring that down. My 10x minus 2x is going to give me plus 8x. And my negative 2 plus 7 is going to give me positive 5. Okay, so now I've got everything on the left side. Can I factor this? Well, I'm not sure yet. But do all 3 terms have something in common that I could possibly take out? What do they all have in common? Well, the answer is nothing, so I can't take anything out. So what I'm going to do is, since there's a number out in front of the x squared that isn't 1, I'm going to start doing rainbow method. So I take the 3x squared, the 8x, and the 5, and I set it equal to 0. And I draw a rainbow from the first number to the last number. Now on that rainbow, I'm going to have to multiply 3 times 5, and that's going to give me 15 at the top. So we are multiplying to 15. That's important to know. But what are we adding to? Well, we're always adding to the middle number, and that middle number today is going to be 8. So I need to find 2 numbers that will multiply to 15, but add up to 8. That's going to be 3 and 5. My 5 and my 3 are going to be the 2 numbers that I need to use. So I break apart the middle term into 5x and 3x. I'm breaking up the middle term into 5x and 3x. And that's because of the 2 numbers that I chose on the right side. Now what I also need to do is I need to bring down my 3x squared on the left side, and I need to bring down my 5 on the right side. So now I have 3x squared plus 5x and 3x plus 5. These are going to form my 2 groups. I'm going to put them in parentheses and see if I can take out what's in common. So for the first set of parentheses, what can I take out? What do they have in common? They only have an x in common. So I can take out an x, but I'm going to be left with 3x plus 5. So this 3x plus 5 is what I'm left with on the inside. I'm going to underline that in green. So now looking at the second group, what can I take out from here? What do they have in common? Well, they actually don't have anything in common. And if they don't have anything in common, I can take out a 1 or a negative 1 based on the situation. And I'm going to take out a positive 1. But taking out that 1 doesn't change anything. You're still left with 3x plus 5. So I'm going to underline what's left in parentheses. And lo and behold, these two parts match up. So I'm going to put what's on the outside in its own set of parentheses, the x and the 1. Those are the GCFs that I took out. But what's underlined, they're going to go in their own set of parentheses, the 3x plus 5. All right, so I was able to factor the left side by using the rainbow method, and I still have it equal to 0. That means I'm going to be setting up my two different equations. My x plus 1 equals 0, and my 3x plus 5 equals 0. So now that I have my two equations, I can solve them both for x. Over here, I need to subtract 1 from both sides, and I get x equals minus 1. Over here on the right side, I have 3x plus 5 equals 0. I can get rid of the 5 first, and then divide everything by 3. So we need to subtract 5, then divide by 3. So I get 3x equals negative 5. Divide both sides by 3, and I get the fraction negative 5/3. Those are going to be my two x values. So over here, I'm going to have a negative 1 and something, and I'm going to have a negative 5/3 and something. All right, so now that I have my x values, I can plug back in, and I'm going to choose the bottom equation. That one's going to be the easiest, and it's definitely going to help when we get to plugging in the fraction. So it's y equals 2x minus 7. Y equals 2x minus 7. And I'm going to put that under both x values. So I plug in negative 1, and what do I get there? 2 times negative 1 minus 7. That's going to be negative 2 minus 7, which is negative 9. So I'm going to take that negative 9 and put it next to the negative 1 here. So I know what my first point is going to be. For my negative 5/3 over here, when I plug that in, what do I get? I get y equals 2 times negative 5/3 minus 7. When I multiply, I'm going to have negative 10 over 3, just multiplying the 2 times 5 here, and I'm still subtracting 7 over here. But I can actually write the 7 with a common denominator, which would be 21 over 3, if you know your math. Okay, so now I have two fractions with a common denominator. So basically, I'm just subtracting the numerators at this point. The negative 10 minus 21, that's going to give me y equals negative 31 over 3. Negative 31 over 3. I can't divide that or simplify it, so I'm going to leave that as a fraction, and I'm going to put it in my last ordered pair. Negative 31 over 3. Okay, so because we did rainbow method, we actually ended up with a fraction, and that's fine. Just as long as the math works, you're probably also going to get a fraction for your y coordinate, and that's fine as well. Okay? Let's do the last one together, number 5. Okay, so number 5 says 2x squared plus x y equals 2x squared plus x. That's going to be my top equation, or my quadratic equation. And the bottom is going to be y equals x minus 4. That's going to be my linear part. So let me label those. Okay, so I have that 2x squared plus x. I'm going to put that on the left side. And I have x minus 4. I'm going to put that on the right side. I need to get rid of the x and the negative 4, so I'm going to subtract x. Do that from both sides. You'll get rid of the positive x. And I also need to get rid of the negative 4. And I can do that by adding 4 to both sides. And I'm going to put the plus 4 right here. Now that's good, because the negative 4 and the positive 4 are going to cancel each other out, and the x and the negative x are going to cancel each other out. So I'm left with a 0 on the right side. So now what am I left with on the other side? Well, I've got that 2x squared that doesn't combine with anything. So I bring down the 2x squared. And the x terms are actually going to cancel this time, because I have an x and a minus x, which is basically 1x minus 1x. So those are going to cancel. And I have a plus 4 under there, which is just a regular number. So it's not going to combine with the x squared term. It's just going to be by itself. So now I have 2x squared plus 4. Can I take out anything that's in common so I can be able to factor it? Yes, I can. I can take out a 2. That way, I can divide everything by 2 and see what's left. So since they both have that 2 in common, I can take out that 2, but I'm going to be left with x squared plus 2 on the inside. Okay, so now at this point, I have 2 different factors. I have a 2 and I have an x squared plus 2. Now the 2 on the outside, you could set that equal to 0, but at the end of the day, that's going to be a nonsense statement, right? You're going to get 2 equals 0, so that's not really going to give you any solutions. We can actually just divide both sides by 2 to save us some time on that. So dividing both sides by 2, what's actually going to happen here is the 2's are going to cancel out on the left side, leaving me with x squared plus 2. And on the right side, I still have 0 divided by 2, which is just 0. So now I need to factor x squared plus 2. Is there any way I can factor this? Well, not really. You might be thinking difference of squares, but difference of squares would require actual perfect squares, right? Which 2 is not a perfect square. So the last method that I use when I've exhausted every other method is called the quadratic formula. So we're going to be using that to solve this. So this is my last resort. I know that ax squared plus bx plus c is going to give me 0. So for this equation right here, what's my a going to be? What's my b going to be? And what's my c going to be? Well, a is always going to be the number in front of the x squared, right? In this case, my a is going to be 1, because there's nothing really in front of the x squared to speak of, so I'm just going to put a 1 in for a. So my a is going to be 1. What is my b? B is always in front of the x, right? And since I don't have an x term, my b is going to be 0. I just don't have that x term. So that's the reason why I'm choosing 0 for b. And what is my c going to be? Well, that's going to be 2. That's pretty simple. So now I know what all my letters are going to be, or constants, I guess you can call them. What we're going to do is we're going to plug into the quadratic formula, which I will list right here. All right, so let's take our A, our B, and our C and plug in. So I get x equals negative b, that's going to be -0, plus or minus the square root of b squared, which is going to be 0 squared, minus 4 times a, which is 1, times c, which is 2. And everything is divided by 2 times a, which is 2 times 1. So I plugged in all my a's, all my b's, and my c. So can we simplify this a little bit? Yes. The -0 right here isn't going to do anything. So all I have is a plus or minus. I'm treating the -0 like it doesn't even exist, which it doesn't. On the inside of the radical, I'm going to have 0 squared, which we know is 0, minus 4 times 1 times 2. That's going to give me 8. I'll have 0 minus 8 on the inside. And what am I dividing everything by? 2 times 1, which is 2. Okay, so simplifying a little bit, I know that 0 minus 8 is going to give me -8. So it's kind of like the 0 shouldn't even exist inside here. So I'm going to write this as x equals plus or minus the square root of -8 divided by 2. Okay, so you probably remember that if you have a negative number inside of the radical, you can actually take that out as an I. So I can write this as plus or minus I times the square root of +8 divided by 2. So the 2 stays the same, the negative comes out as an I, and I'm left with a +8 on the inside because I took out that negative sign, right? I took it out as an I. That's important. So the I is going to stand for the imaginary unit, which you remember is the square root of -1. That's why I can take out that negative. So what's the last thing I'm going to do? I'm going to simplify the square root of 8. So can we simplify square root of 8? Yes, we can. We can actually take out squares, right? So 8 is 4 times 2. I can write that as 4 times 2 on the inside. So instead of having that 8 on the inside, like I do right here, I can write that as 4 times 2. And that is correct. Now, the reason why I did that is because I wanted to write the 8 as 4 times 2, because I know that I can take the square root of 4. That's not going to be a problem for me. So what's the square root of 4? That's going to be 2. I can take the 2 outside the radical, and I'm basically left with plus or minus I times 2, and then that other 2 that's left under the radical, that has to stay there. And everything is still divided by 2. So I've got a lot of stuff going on. The 4 just came out as a 2. I still have a 2 left under the radical, and I'm dividing everything by 2. So what's going to happen here is the 2's on the top and bottom are going to cancel, right? Those are gone. So that's going to simplify it a little bit, right? I'm going to be left with x equals plus or minus I square root of 2. Now, since I have a plus or minus out in front, that means that it could be a positive or a negative. So I could have positive I times the square root of 2, Or I can have negative I times the square root of 2. And I'm actually going to have both because that's what the plus or minus kind of implies, right? So these are going to be my x values. And because these are my x values, they are imaginary x values. Imaginary. Why are they imaginary? Because of the I, right? And if they're imaginary, then they're actually not going to show up on my coordinate plane. Because when I plot my points x comma y, I need real numbers for x and y. I don't need these imaginary numbers. So even though they do solve the system, they're not going to show up on the graph. They're not going to show up at all. So this one is going to be, you probably guessed it, no solution. I can write no solution, or I can write the empty set, which is the set of no solutions, right? Okay, now since there's no solution, I don't really need to find my y values, so I'm not going to worry about that. The answer for this system is that the two graphs don't cross at all, and I'll show you that in a little picture. All right, let me go drag out my calculator. Okay, so I've got to go to y equals, that's at the top, and I can plug in whatever I want for y. So the top equation was what? 2x squared plus x. Let's put that in. 2x squared plus x. You can also do this on Desmos. You'd be typing in y equals 2x squared plus x. Same thing. Now the second equation is x minus 4. So now I basically got this. I put in the two equations and I hit the graph button at the top. Let's see what we get. We get that U shape and we get a line. Perfect. So what you'll notice is the U shape does not intersect with the line. The parabola is not crossing with the line. So we can say that this system has no solution. No solution. All right, let me show this for a few more minutes. Now, let's talk about your homework. Today, you're going to be doing classwork 2. This is going to be 5 questions, and they're all going to be solved the same way, exactly like we solved every single one that we did today. So your classwork is going to look like this. 5 questions. Some of them might be no solution. I'll let you guess which ones they are. If they do have a solution, I want you to write it as an ordered pair, x comma y. Okay? And if you want to check your answers at the end, want to see if you did your math right, you can go to Desmos, or if you have a graphing calculator, you can do that too. Either way is fine. So that's it. Class dismissed. Go ahead and get your homework done. And if you have any questions about these 5 that we did today, stay after for 5 minutes. I'll be answering questions in the chat box. I will see you on Monday.